Okay, so let us come up to this problem. It's a simple one, looks like a simple one. For the opamp circuit below, find the current I naught. So obviously we would be sooner or later, we may have to find this VO, not necessary, but we may have to. So what we know, we have 0 volt here. We have a current of 2 milliampere flowing in this branch in this direction, and we know there would be no current going in or flowing out of here, so all this current must be coming from this branch, 2 milliampere, and this is 0 volts. So and the current is going this way, is a positive current flowing this way, and this must be the higher potential and this must be the lower potential, so we expect that it would be something in negative. And 2 milliampere multiplied by 3 kilo ohm is going to yield a voltage of 6 volts across this resistor. So if this is the higher potential, this is the lower potential, this must be at minus 6 volts. Minus 6 volts. So if the higher potential is 0, the lower potential must be minus 6 volts for the thing to have 6 volts across it. If this is minus 6 volts, this must be minus 6 volts based on the ideal op-amp characteristics. This is 0, this is 10. We can very easily find this current and the voltage. Okay, let us solve it from the currents this time. So this is a higher potential, this is a lower potential. We know that the current is going to flow this way, and that value of current would be 10 minus the other voltage, and this minus is because of the finding the voltage across it, and this is the negative because of the value. Don't mix the two. We are going to get something like this. 16 over 4 means a current of 4 milliampere flowing here. It cannot go in here. All the current must go in here. A 4 milliampere current flowing this way is going to create a potential difference this way, and 4 into 5 is 20, so 20 volts is going to appear across this. If this is at minus 6 volts, we are at the higher potential. It means we are going to drop down in potential by 20 volts. So minus 6 and a further drop by minus 20 volts mean we reach at minus 26 volts at the other end. So we have a current of 4 milliampere coming from this side. This voltage is minus 26 volts. We want to find this current. We need to find this current. So this is 0 volt, this is a negative voltage, so the current would be flowing from this to this side, and the value would be 0, this side's voltage, minus the other side's voltage, minus 26 divided by 2, which is a current of 13 milliampere. So 13 milliampere coming from here, 4 coming here, the join here, and the flow inwards. So I naught is equal to 13 plus 4 milliampere, that is 17 milliampere.